There's a man named Bill Gray who sits in front of a computer screen most days, tracking things that most people have completely forgotten about. He is not famous. You have probably never heard his name. But on August 5th, 2026, at 6:35 in the morning, Universal Time, something he predicted would happen actually happened, and it changed how we think about space debris, lunar safety, and the future of human exploration beyond Earth. This is his story, and the story of a school bus-sized piece of forgotten hardware that became an accidental messenger, traveling through space for 18 months before finally arriving at a destination nobody intended. Let's start back at the beginning. On January 15th, 2025, SpaceX launched a Falcon 9 rocket from Kennedy Space Center in Cape Canaveral, Florida. This was not a routine mission, though SpaceX launches hundreds of rockets every single year now, and routine has become almost meaningless when you apply it to space operations. Inside that rocket were two separate lunar landers. They came from different companies, they came from different countries. They shared one ride into space. The first lander was called Blue Ghost, built by an American company named Firefly Aerospace. The second was Hakuto R, a Japanese spacecraft built by a company called ISPACE. Two separate teams of engineers, two separate sets of scientific instruments, two separate national interests, all riding atop the same Falcon 9 rocket's upper stage. The rocket did what it was supposed to do. It pushed both landers on their separate journeys toward the moon. That was a win. That was the kind of thing that makes aerospace engineers smile. Hakuto R, meanwhile, attempted to land but failed to make a successful touchdown. That was a loss, the kind that stings when you have invested years and millions of dollars into a project. But here is where the story takes an unexpected turn, the kind of turn that most people never see coming. After the Falcon 9's upper stage completed its job of pushing both spacecraft toward their destinations, it had no more fuel. This is a massive piece of hardware just sitting in space with no engines, no fuel, no way for anyone on Earth to steer it or bring it home or guide it toward any particular destination. Normally, Falcon 9 upper stages do not travel very far from Earth. They orbit close to home. After they complete their jobs, Earth's gravity pulls them back down into the atmosphere and they burn up in an impressive flash of heat and light. Clean, gone, problem solved. But this particular upper stage ended up much farther out in space than usual. It spent most of its time at a distance close to the moon, and that changed everything about what would eventually happen to it. Out there, far from Earth, different forces start acting on objects in ways that most people never think about or understand. There's the gravity of the sun, there's the gravity of Earth, there is the gravity of the moon. And there is something else, something that sounds almost impossibly gentle, something that almost nobody considers when thinking about orbital mechanics and space physics. Sunlight itself pushes on objects. It is called radiation pressure. It is barely noticeable on a day-to-day basis. But over 18 months, these forces, working together in a kind of cosmic choreography, slowly and silently nudged that rocket stage into a new path. That new path had a destination, and that destination was the moon. This is where Bill Gray enters the story. Bill Gray is not someone you see on the news every week. He is not a household name. He is not the kind of scientist who gets invited to talk shows or who publishes papers that make headlines in major newspapers. But Bill Gray is the person who spends his time doing something that almost nobody else does. He tracks objects in deep space. He tracks things far from Earth, objects that most tracking systems completely ignore. He has been doing this work for about 30 years. He developed software tools that help distinguish between actual asteroids and man-made space debris floating in similar orbits. When asteroid surveys scan the sky and find something unexpected, something that might be dangerous or might be important, they call Bill Gray and ask him what they are looking at. Back in September of 2025, Bill Gray first noticed that this Falcon 9 upper stage was on a trajectory that looked concerning. He started running the numbers. He checked the math again and again over the following weeks. He ran the calculations multiple times, watching how the orbit was evolving, watching how those gentle forces we talked about were pushing the rocket stage incrementally into a new path. Slowly, the picture became clear. This piece of rocket was going to hit the moon. It was not going to miss. There was no engine, no fuel, no way to change course. It was locked in. The collision was inevitable. He was not alarmed in the way you might expect someone to be when realizing they have just discovered something catastrophic. He had been watching for this kind of thing for about 20 years. He had been waiting, essentially, ever since there started to be many large pieces of debris in orbits that could theoretically reach the moon. When he talked to journalists about his discovery, he said he was surprised only that it had not happened more often. In all of human spaceflight history, only 2 objects had ever been confirmed to hit the moon accidentally. The first was way back in 2022, and now this would make 3. As the months went on through the rest of 2025 and into 2026, the predicted impact time became more and more precise. Bill Gray kept refining his calculations. He kept watching the numbers. He kept updating his predictions. The final estimate was incredibly precise. 6:35 in the morning, Universal Time, on August 5th, 2026. That translates to 1:35 in the morning, Central Daylight Time, for anyone in the United States watching the event unfold. The predicted location was near a place on the moon called the Einstein Crater, close to the western edge of the moon as seen from Earth. Scientists at NASA and independent observatories around the world started preparing. But this was not a disaster to avoid. This was actually an opportunity. A known object of known size and weight hitting the moon at a known time and location. That almost never happens in astronomy. When asteroids hit the moon, they come without any warning. When natural impacts occur, scientists have no preparation time. But this one was marked on the calendar months in advance. Scientists could point their best instruments directly at the right spot and wait. They could prepare their cameras. They could position their telescopes. They could get ready to capture data in a way that is almost never possible. On July 17th, 2026, a group of researchers published a scientific paper specifically about how to observe this event. They calculated the best angles. They figured out the best timing windows. They determined which telescopes would have the best chance of catching the impact flash or the dust plume that would come afterward. 1 week and a half before impact, another research team from the University of Texas at Austin published their own paper, modeling exactly what the impact would look like. They predicted the central dust plume would rise between 45 and 60 meters above the moon's surface. The cloud would spread outward about 113 miles in every direction. This plume would be many times brighter than the dark sky around it for the first few minutes after impact, potentially visible through telescopes equipped with high-speed video cameras. The researcher who led that University of Texas study, a scientist named William Joe, specifically warned observers about something important. He said the real science would not be in the 1-second flash of the impact itself. Most observers, he predicted, would likely stop recording after they caught that initial flash, thinking they had captured what was important. But the ejecta plume, the cloud of material flying out in every direction from the crater, that was where the real science lived. That was what would tell scientists the most important information. He wanted people to keep watching after the initial impact. He wanted them to focus on what came afterward. Now, let's talk about what actually happened on August 5th, 2026. At 6:35 in the morning, Universal Time, the rocket stage hit. The European Southern Observatory's very large telescope, which sits in the Atacama Desert in Chile, was already aimed at the moon and ready. Astronomers across the Americas had their equipment positioned at the impact zone. And then it happened. That 4,000-kilogram hollow metal tube slammed into the lunar surface at 8,700 kilometers per hour. That is roughly 5.5 kilometers every single second. The moon has no atmosphere. Nothing slows anything down when it hits the surface. The force of that impact was equivalent to roughly 3 tons of TNT exploding on the surface. Within minutes, the European Southern Observatory confirmed what their instruments detected in the plume of material blasted off the surface. They found chemical signatures of 2 elements, sodium and lithium. The sodium, scientists believe, came from the lunar soil itself. The moon's surface contains sodium compounds that get released violently when something impacts it with that kind of force. The lithium, however, was different. Lithium is a key component of the batteries inside rocket hardware. Scientists believe that lithium reading came from the rocket itself, from the batteries still embedded in that hollow metal stage, from hardware that had been drifting through space for 18 months and was now scattered as gas across the lunar surface. This was already remarkable. Scientists had a chemical fingerprint from both the moon and from the rocket mixed together in a single plume that drifted through space for 5 to 10 minutes after impact. 1 day later, on August 6th, the Korean Aerospace Administration released images taken by South Korea's lunar orbiter called Danuri. This spacecraft had been repositioned to watch the impact zone. They conducted 8 separate imaging sessions, one image taken about 30 minutes before impact, and then 7 more images taken afterward. When you line those images up and compare them, there's a dark streak visible in the after images that simply was not there before. A mark on the moon, a new scar. The crater itself is not yet precisely measured, but scientists expect it to be roughly between 20 and 30 meters wide, somewhere between 65 and 100 feet across. That is significantly smaller than the crater that would be created by a solid object of the same weight like a metal asteroid. The reason is that the rocket stage is hollow. When something hollow hits at high velocity, the energy of the impact is spread differently than when a solid, dense object hits. The crater shape and size is actually one of the data points scientists are studying most carefully because they want to understand how human-made hollow objects behave differently from natural solid impactors. NASA's Lunar Reconnaissance Orbiter, which has been orbiting the moon for years and has a long track record of imaging impact craters, has also been tasked with surveying the impact site. Scientists expect to eventually have much clearer and higher resolution images of the new crater, similar to what happened when that 2022 impact was documented. Let's go back to that 2022 event for a moment because it is the closest comparison to what just happened. In March 2022, Bill Gray tracked another piece of rocket debris on a course toward the moon. There was actually initial confusion about which rocket the debris came from. Some thought it was an old SpaceX Falcon 9 rocket body. Others later determined it was part of a Chinese Long March 3C rocket that had been launched way back in 2014. Either way, it hit the moon on March 4th, 2022. When NASA's Lunar Reconnaissance Orbiter photographed the site, the images showed something unexpected. Not one crater, but two overlapping craters, each roughly 100 feet across, sitting right next to each other. A double crater. Scientists had not seen that before from a single natural impact. The theory is that the hollow rocket body, when it hit, had different mass concentrations at different points along its length. So the energy was released in a way that created two separate impact points almost simultaneously. That is the kind of weird, interesting, unexpected data you only get from an actual impact, not from computer simulations, not from theoretical models, but from the real world colliding with itself at high velocity. Now, with the August 5th, 2026 impact, scientists have even more preparation, better instruments, and hopefully better before and after imaging. What they learned from this impact is not just interesting for its own sake, it has real practical value for the future. Here is the bigger picture that this crash sits inside. NASA, SpaceX, and several other space agencies are all working towards sending humans back to the moon. NASA's Artemis program has already announced the crew for Artemis 3, which is scheduled for 2027 and is intended to land astronauts on the moon's south pole for the first time. SpaceX is a key part of that mission. SpaceX's Starship, the biggest rocket ever built, is the vehicle planned to actually land those astronauts on the lunar surface. But before any of that can happen safely, scientists need to understand the lunar environment in great detail. They need to know how dust behaves when something hits the surface. They need to know how craters form. They need to know how material gets distributed across the surface during impacts. Because when you land people on the moon, and when you eventually build structures on the moon, and when spacecraft are launching and landing repeatedly, impacts and debris become serious safety considerations. An astronaut on the surface cannot be hit by a piece of ejected rock moving at high speed. Equipment and habitats cannot be damaged by impact debris. Understanding how these events work from real data rather than just computer models is directly useful safety information. The researcher William Joe from the University of Texas made this point directly. He said that every future thing we deliver to the moon depends on having good models for impact, ejecta, and plume dynamics. This rocket crash gave real-world data to calibrate those models against. That data did not exist before. Now it does. But there is another dimension to this story that is harder to ignore. Juliana Scheiman, who is SpaceX's director of NASA Science and Dragon programs, addressed reporters 2 days before the impact. She said the trajectory that led to the crash was unintentional but unpreventable given the remaining fuel reserves of the vehicle. That is an honest statement. SpaceX is not pretending this was planned or that it reflects good practice. The rocket ran out of fuel and was at the mercy of gravitational forces that nobody could override. Bill Gray, the astronomer who tracked the object, offered a quote that stuck with people. He said this event does not present any immediate danger, but it does highlight a certain carelessness about how leftover space hardware is disposed of. He added that things are getting crowded up there. That phrase, things are getting crowded up there, is one you're going to hear more often in coming years. Right now, there are hundreds of thousands of pieces of space debris in orbit around Earth. Most are small, but some are large. Most are tracked, but some, especially the objects in higher orbits farther from Earth, are not tracked well at all. Gray himself has acknowledged that he is essentially the main person tracking objects like this Falcon 9 upper stage. High-altitude junk, as he describes it, mostly goes ignored except by him. The rules around space debris disposal are not as strict as they probably should be. For objects in low Earth orbit, there are guidelines about how quickly spacecraft must re-enter the atmosphere after completing their missions, with the goal being to reduce the time they spend as debris. But for objects that go higher, like this Falcon 9 upper stage did, the rules are much less clear and much less enforced. Space is about to get a lot busier. SpaceX launches dozens of Falcon 9 rockets every year. Other companies around the world are launching more and more. China is dramatically increasing its launch cadence. Private companies in multiple countries are sending spacecraft to the moon with increasing frequency. Each of those launches produces upper stages, fairings, hardware of various kinds that must go somewhere after the payload is delivered. The vast majority of that hardware burns up safely in the atmosphere, but not all of it. The fact that only 2 confirmed accidental rocket impacts on the moon have occurred in all of human spaceflight history is actually somewhat remarkable, given how much hardware has been sent into space over the past 65 years. But as launches multiply, that number will not stay low forever. The moon is about to become a much more active place. NASA plans human missions. China plans human missions. Robots and rovers from multiple countries will be on the surface. Commercial landers are being sent with increasing frequency. If rocket debris starts hitting the moon more often, and if any of that debris happens to hit near active missions or equipment, the consequences could be serious. So this impact, as strange and as dramatic as it sounds, is in some ways a useful wake-up call. A school bus-sized rocket crashed into the moon. It created a new crater. It sent sodium and lithium gas drifting into space in a plume that lasted nearly 10 minutes. It was photographed by a South Korean spacecraft. It was chemically analyzed by some of the most powerful telescopes in the southern hemisphere. It was predicted, tracked, and documented by a small network of astronomers who do this work quietly outside the headlines year after year. There is something almost poetic about the whole sequence. A rocket built to send 2 different landers to the moon for 2 different private companies from 2 different countries ended up going to the moon itself in the most unplanned way possible. It did not soft land. It did not complete a mission. It crashed, and it left a mark that will be there in that crater near Einstein essentially forever. The moon has no weather, no wind, no erosion. That crater will sit there for billions of years. Long after SpaceX, long after Elon Musk, long after every person alive today, that crater will still be on the surface of the moon, a permanent record of something that was never intended to happen. Scientists, the people who actually live and breathe this data, are poring over the before and after images from Denuri. They are analyzing the spectroscopic data from the Very Large Telescope. They are waiting for the lunar reconnaissance orbiter to pass over the site and send back clear images. And they are writing papers and building better models and updating the simulations that will eventually help keep future astronauts safer when they actually step out onto the lunar surface in 2027. That is the thing about real science. It is not always clean or planned. Sometimes the most useful data comes from something that nobody intended to happen. A piece of forgotten hardware drifting in deep space for 18 months, pushed by gravity and sunlight and forces so gentle they barely registered. Until one morning at 6:35 UTC, it finally arrived at its destination. Not with a mission, not with a crew, just with momentum. And one astronomer named Bill Gray, who has been watching things like this for 30 years, mostly alone, mostly without headlines, saw it coming months before it happened. He did not have an aha moment. He said the certainty came gradually. He just kept watching, kept running the numbers, kept refining the prediction, and he was right. The moon got a new crater on August 5th, 2026. It was not the moon's first, and it will not be its last, but it was the most observed, the most anticipated, and in some ways, the most meaningful. Because what scientists learn from this crash will directly shape how we go back to the moon as a species and how we try not to leave more of our trash behind when we do.